Hey everyone, welcome back. Today we're going to take a look at porting shaders from Shadertoy to TouchDesigner. We've looked at this before, but today is going to be a little bit different because we're going to focus on porting multipass shaders. When I say multipass, what I mean is shaders on Shadertoy that use multiple buffers to contribute to the final image. My last tutorial about porting used a single buffer shader, and most of the other resources out there that talk about how to get something from Shadertoy to TouchDesigner all use that single buffer case as their example. So I wanted to do this to expand that a little bit. And so what we'll be doing is taking this expansive reaction diffusion shader and porting this in all of its buffers over to TouchDesigner. So I have a blank TouchDesigner open right now, completely blank, and this is what we'll be using for our port. So first of all, kind of the overall structure. The overall structure, as you probably remember or have seen, is that Shadertoy uses a couple different function names, a couple different uniform names that we have to change. And if you haven't looked at the other Shadertoy tutorial that I've done, I'd recommend just taking a quick spin through. It's not very long. And that'll go over some of the more kind of basics for this. I will be breezing through those a little bit here. So the key thing to understand about this multi-buffer shaders in Shadertoy is that each of these buffers is really just a different GLSL top in TouchDesigner. So for a setup, what I'm going to do is just take a GLSL multi. I'm going to call it buffer A. And I'm going to add some uniforms. I'm going to use, so in this case, I'm actually just going to use the buffer or the uniform names that I know exist, meaning eye resolution, eye time, and eye channel. The reason for that is because I don't feel like going through and renaming all of these variables in my shader, but generally I like to rename them to things like U time, or U mouse, or U resolution, but yes, I'm going to be lazy today because I don't have a ton of time to record this. So I'm going to set up this buffer A with all of these different variables. I'm going to go ahead and just collapse this already. And Shadertoy port multipass is what I will call it. And I'll jump inside the component. And the reason that I did that is just so that I can have a couple of these parameters and just kind of start to change my resolution and some other things in a more easy way. So I'm just going to set everything on buffer A up really quickly, and then we'll copy and paste it for the rest of our buffers and look at wiring everything together. So like I said, we have our resolution uniform, which I'll associate here. We have eye time, so I'm going to call that abs time dot seconds. And then the mouse. So we can use a mouse in. Now, based on my screen setup, my mouse I know goes from -1 to 1 on the X, so I can take a math and I can remap my TX only from -1 to 1 to 0, 1. Scale X, and then I'm just going to use another math. This will be scale Y, and then I know that my Y in this case goes from minus aspect ratio to aspect ratio, and this is a 4K screen, so I can just do minus 2160 over 3840 to 2160 over 3840. And so now I have a nicely mapped out 0 to 1 for my mouse. That's not essential, but obviously it's nice to have something that's easily properly mapped. And then I'll just drag and drop this onto my shader for my mouse uniform. So now that all of that's set up, we can first just kind of copy and paste these other buffers in. So this I'm going to call buffer B. And then this one will be buffer C. And buffer D. And then we'll have one more. And then this one we will call our main image. Okay. And so now all of these have our nice uniforms all set up. And we have one for each of these buffers. So now we can move into the kind of port portion of this. Now, one thing I'll just mention before we start, this shader doesn't have any listed licenses, so it should be pretty much okay to use. But a lot of the shaders on Shadertoy have licenses, and some of them are pretty restrictive, so definitely make sure you check the licenses of whatever shaders you're porting, and make sure that it's okay with the author that you're going to be using it in whatever use case you plan on. Okay, so now to start porting. First things first, we can just copy and paste the code from each of these buffers into the respective pixel shader. And so I'll do that here, and maybe I'll try and move down. I apologize, there's a lot to fit on the screen right now. But I think this is good. And then one thing that I like to do when I'm copy and pasting shaders like this is just up here in the first line, give myself a comment that says buffer A, and so that way I can just see it in my network editor a little bit easier and make sure that everything is associated. So then we have buffer B, and we'll come back and edit each of these in turn. Buffer C, buffer D, and then our main image. And as you can see, I'm literally just copy and pasting each of these things. And so now we have all of our different shaders. I'll just make sure that I label those. This will be buffer D, buffer C, and this labeling is also helpful for just being able to make sure you're on the right shader in VS Code, because the TouchDesigner file names aren't very descriptive sometimes, especially if you're not using externalized stats. So, okay. Now we've got our shaders all ported over. Now the last thing that we have to kind of extract from Shadertoy and rebuild on our TouchDesigner side are how the buffers interact with each other. So in TouchDesigner, we wire stuff together, and that kind of says, do this calculation first, then do the next calculation, and so on and so forth. In Shadertoy, it's a little bit more convoluted. But we can trace what's happening by using the different channel associations on each buffer and kind of thinking about those channel associations and buffers as different inputs in TouchDesigner. So what I mean by that is here on our image, in the main image tab, we can see that we're using A and C here as the iChannel 1 and iChannel 0. And so what this means is that buffer A and buffer C are the channel inputs for this specific pass of the shader. Now, in TouchDesigner land, what that means is something along the lines of selecting the output of buffer A, which we'll use a null. And we'll say, I'm just going to call it A. We will select A, and then we can also select C. And then our output from C will be another null that I'm going just going to call C. Now, apologies, this will become a little bit more organized in a second once we have more understanding of what's going on. Buffer D is down here. And then we have our A and C. So A and C, our selects, will just be wired into our main image, just like this. And then if we just use Alt-N and drop a null and maybe call it out image, this will be our final and what we'll be viewing. So here we're selecting our buffer A output and selecting our buffer C output. And so that is what is going to be our iChannel 0 and iChannel 1. So in our main image shader, we can update this one first. We will, of course, have to rename that main function, get rid of those arguments, create a frag color variable. It's a vec4 for the output. And then we'll want to replace this frag chord with gl underscore frag chord.xy. And then we'll just want to use our debugging errors to make sure that we are resolving all of the other dependencies. So this looks like iResolution is not defined. That's because we have the uniforms on our shader, but not in our code. So we can define a uniform vec2 iResolution and a uniform vec2 iMouse, and then a uniform float iTime. And I'm just gonna go ahead and copy and paste actually all of this in the rest of our buffers real quick, because we're going to need those on all of them. Back to our main image, and I know we're working backwards, but it should kind of make sense once we get there. Okay, so now our next error is that we have iChannel 3, which is an undeclared identifier. We need to replace that with something. And so we can actually see here in Shadertoy that iChannel 3 is just this random noise texture that is just like RGB random noise. And so we can replace that by just using a noise, setting it to random, turning off monochrome. We'll give it 32-bit, and then we'll make its resolution the same size as our other resolution. So now here we can come in and we can just define our textures real quick. A will be 0, C will be 1, and then noise will be 2. So then instead of iChannel 3, we can just use std2d inputs, and in this case we'll grab our noise texture. This is dividing it by the channel resolution of that input texture, so we don't actually need that. We can do std2d infos and then grab noise again like this, and then res and zw will be the integer, so in this case like 1024 by 1024. So this is the TouchDesigner equivalent of that iChannel resolution. Okay, it looks like that std2d infos. Oops, it should be utd2d infos, I believe, not s. And then, okay, so now we are at iChannel 2. So iChannel 2 is just this black surface. So we can very easily just replace iChannel 2 with a constant. And so as you can see now, a lot of what the actual kind of work here is importing multipass shaders is unraveling rather what the different buffers actually mean and the different channels for each buffer, and then just making sure that we can recreate those in some easy manner. So this will be, I'm just gonna define it as black for now, and that'll be our third input. So now we can replace this iChannel 2 with std2d inputs black, like that. We can replace iChannel 0 with std2d inputs. In this case, we know that iChannel 0 is buffer A, and we have defined buffer A as our 0th input as well. So we can just use std2d inputs of input A to replace iChannel 0. And then iChannel 1 would be replaced by buffer or input 1, which is C. It doesn't actually look like iChannel 1 is actually used in the shader at all. So that doesn't need to be replaced, but that is how we would do it. And now you can see that we're out of compile errors, and that at least this main image is kind of accurately rendering itself. So now that we have our end image and kind of something to work towards, we're just going to repeat this process with the rest of our shaders. And so we'll go back to the very beginning, and we'll start with buffer A. So buffer A has 3 inputs, and that's buffer A, buffer C, and buffer D as channels 0, 1, 2, and then it has this random noise texture as channel 3. So what that means is that we need not only these other selects to get buffer C and D, but we also need to get A itself, which means we're going to need a feedback. So we can just use a constant that I will initialize to the resolution that we're rendering everything at. And then we use a feedback. And then a null, and I'm going to call this buff A feedback. This feedback top will obviously point at the output of our buffer A. We see that buffer B also takes in buffer A as an input, buffer C takes in buffer B, and then buffer D takes in buffer A. So what that means is we can kind of just wire these in together. We can wire A directly into B, B directly into C, and then for D, this actually looks like it's not used, and we never use buffer D in the main image either, so I think we can just skip buffer D and not worry about that one. Then we just need to select our buffer B and buffer C. So I'll input a null real quick after buffer B, because I should have done that. I'll drag and drop that on my select B. I'll drag and drop the output of my buffer C onto my select C. I'll wire those bad boys in. Then I'm going to select, in this case, my random texture that I've already created over here. And then that will be my third input. So at this point, we can go, actually maybe we'll just get rid of our Shadertoy for now. And so we're back to buffer A. Now we need to basically just work through all of those ports again. And the best way to do that is going to be to also just set up some defines. So I'm going to define A as 0. That's my, again, buffer A input. We'll define B as 1. Define C as 2. And then define rand as 3. Now I can go through and first I will look for iChannel 2. I will replace that with, again, my C input, so that's actually ready to go already. Just replace. Look at so I'm not actually sure what this mouse ZW means. So we can go to Shadertoy and maybe look and see if there are inputs, and it tells us that, there we go. So the U mouse or I mouse has the mouse pixel coords, XY current, and then ZW is click. So I assume ZW is going to be 0 if it is not clicked and 1 if it is clicked. So we can easily just give ourselves a left channel that's going to be our click. And then in buffer A, in this mouse, we can just drag and drop that C channel. Now this SY, I need to make sure that I'm only applying that to my TY channel. I messed that up originally. So now our C is from 0 to 1. Okay, so now our U mouse should be a VEC 4 in this case, and we'll just make sure we're using our click value for both Z and W. Now we have to replace iChannel 1 with our input B. And then iChannel 3 is with our input rand. And then iChannel 0 is with our input A. Now it's telling us on line 117 we're running into that same other uniform here, so we can replace this with UTD 2D infos, and instead of 3 we'll use our defined rand, and here instead of XY we want ZW. And I forgot to do something. It needs to be .res.zw to get the right field. Now we have an iframe variable or uniform, which is used here but wasn't assigned before. So that's easy. Uniform int iframe. And then we can add that here and call me.time.frame for that uniform. Now, this weird looking error means that we need to redefine our main function and get rid of those arguments. And then finally, we can replace frag chord with just GL underscore frag chord. And there we go. Now we have our buffer A working. It says there's a cook loop detected. That's fine. We probably just need some feedbacks in here, which we can take care of once we kind of have everything working. I may as well move on to B now. and I believe these should be a little bit faster. So for buffer B, channel resolution, that is our main issue. I'm gonna go and just keep following our best practice and define my input A as the 0th input here. And then u2d 2d infos dot u2d 2d infos utd 2d infos, and then I'll grab the entry that corresponds to my buffer A dot res and then dot zw. Channel 0 obviously needs to be replaced with that std 2d inputs using our input A. And then we'll just rename our function just like that, and make sure that you don't forget the parentheses. And then we will just do our GL frag chord update. And there we have our buffer B. Now, finally, in buffer C, we know that we are defining our input B as the 0 input. And so I'll just take care of this main function now. We'll replace iChannel 0 with std 2d inputs, our B input. Just go over here and copy and paste this whole TD uniform and just change that from A to B. And then frag chord, we can just do GL frag chord update. And just like that, we are now running our buffer C. So now all of our different buffers appear to be working. We do need, I believe, to add some feedback. So instead of this selecting B and C here, I want to actually use some feedbacks. And I will just point this feedback at buffer C and this feedback at buffer B. And then I'll use these instead of my selects to get rid of that cook loop warning. I'll just get rid of this null, and then I will rename these feedbacks a little bit more descriptively. Feedback A, B, and C. So now we have a ported shader that is kind of working. Now we want to update our mouse, I believe, with our click value in our output image. And then we can get rid of our buffer D since that was never actually used. And it looks like we're resetting after our frames, so maybe I'll just add a bunch of frames so that we don't end up resetting. And then we can just try and figure out maybe why the mouse isn't moving. And we should probably try resetting all of our feedbacks. So at this point, we can also try to start changing different colors or different textures and just kind of start playing with the shader. And this is, I don't think, working exactly properly as it's supposed to right now. It looks like this checkerboard pattern, probably not meant to be there. We can add a transform to make it opaque in the background. Again, resetting our timeline, we'll reset the simulation. We can drag and drop this reset pulse onto all of our feedbacks so that we can reset our feedbacks easily. And then we just have to figure out why the mouse isn't moving. And so for that, we can basically go in our different shaders and just see where the mouse is being used. This is in buffer A. So my guess is that, yes, okay, so we don't actually want this mouse being divided by the resolution there, because that means that our mouse, we're already using a normalized 0 to 1 for our mouse, so we don't need to be dividing it by the resolution. And we also don't, I think, shouldn't need that either. Aha. And so now we're starting to see some movement, although I think it's kind of crazy because of why. Well, let's look also in our main image at what we're using the mouse for. Yes, so we are also adjusting our main image. We're adjusting the mouse coordinates for the pixel width, which we shouldn't need to do because, again, we're using normalized coordinates there. Okay, so now we can see that our mouse is moving around much more similarly to how we would expect. And it looks like we just need to be centered on 0, 1 and not, or sorry, on 0 and not 0.5, 0.5. So I'm just going to tx, ty and range from 0, 1 to minus 0.5, 0.5. And so now you can see that my mouse is being tracked, and clicking is doing something. Clicking, I think we need to go back to A here, and I actually think that maybe our click should still be divided by iResolution.xy. And the reason I think that is because it looks like we're comparing basically like if the click is bigger than a pixel size, and so I think that might lead to better results. And yeah, we can see now that it's a little bit less crazy. And reset all of our feedback. And now we have a nicely mapped reaction diffusion setup that looks very similar to our shader on Shadertoy. So yes, I'm going to leave things there. Hopefully this is pretty clear explanation on how to port over multipass shaders and how to think about the different buffers and kind of how they relate to TouchDesigner and how we can port them and then start to use some Shadertoy shaders in our TD work. So that's all for today. Thank you very much, and until next time. I want to thank everyone for all of your support. It really means a lot, as always, and yeah, I will see everybody soon with another video.